A pump lifts water from a lake at a large tank to a large tank 30 meters above the lake. So I have a lake and I lift the water to a tank at a height h 30 meters. How much work against gravity? Work against gravity is mgh. This is the work done against gravity. Does the pump do as it transfers 5 cubic meter? This is m cubed, 5 cubic meter of water to the tank. But we don't use a cubic meter is a volume actually, right guys? This is a volume. And we don't use volumes. We don't use volumes in our equation, but we use mass. So he says here 1 cubic meter of water has a mass 1,000 kilogram. 1 cubic meter equals 1 ton or 1,000 kilogram. So the 5 cubic meters, what? It's 5,000 kilogram. So he's asking here, how much work against gravity does the pump do as it transfers 5,000 kilogram water to the tank? So I have 5,000 kilogram. I want to lift it up a certain height, 30 meters. So how much work is it? How much work? mgh, the mass, 5,000 kilogram, times 9.8 times the height, 3 meters. Do you have calculators, guys? Please have a calculator and try to do it. Hussam says it's what? 1470000. So it's 1470 kilojoule. 1,000 means a kilo. Okay, so that's 1470 kilojoule. Okay, guys? So the right answer is number A. Let's say, yeah, go ahead, Asil.
Why we type 3?
Why
the high is 13, right?
Yeah, right. Height is 13.
What is it? 30 meter. 30.
Yeah, we type. Okay. I get confused because I see 3.
I forget the 0.
Yeah.
يا أخي سبحان الله, it's now 3:30, so I forget it. Okay.
Doctor.
Okay.
Doctor.
Go ahead.
It's mgh is potential energy.
mgh also is a potential energy. We said before, if you do work to lift something up, so now you convert your work into some kind of energy and you store this energy in the object. So when you lift the water up, that means you save energy inside the object. This energy equals to the work that you did. So the energy also is mgh. So you do a work mgh and you convert this work into a stored energy or potential energy. That's right. Okay, that's a good question. Let me add another question. If the pump transfers the water in, let's say, 1 minute. In 1 minute. Of course, it will be more than 1 minute, but let's say 10 minutes. 10 minutes. In 10 minutes. Find the power. Find the delivered power. The delivered power of this pump. It will be the work divided by what? Divided by time. So the work is 1470,000 joule, or you can keep it kilojoule, and we can get it kilowatt at the end, kilojoule, divided by the time. You need to change 10 minutes into seconds. So 10 times 60. What's the result? You need to convert it into seconds. So what's the result, guys? 240, 2450. Okay, so but this is what?
Watt. Joule
This is
per
watt,
second.
not kilowatt. This is watt, not kilowatt. Okay, so it's 1470 divided by the 600. So it's 2.45 kilowatt, or as you said, 2450 watt. So this is delivered power. Okay, so we can make two problems. We can make a problem like find the work, or we can ask find the power. Yes. Let's do another problem. The same one. We will do another problem. Let's make another one. If the pump, there is a pump here. Pump مضخة. If the pump consumes energy 3000 watt. 3000 watt. Find the efficiency of the pump. If the pump consumes تستهلك 3000 watt of energy coming from the electricity, from the power line. Find the efficiency of this pump. The efficiency of the pump will be output work over input work, or output power over input power. The output power here is what? You calculated 2450 watt. And the input power is the power coming from electricity, 3000 watt. We don't need to write the watt. Times 100. Huh. How much is it, guys? 81? 81.66%. So we can make another problem. Okay? Huh. You have a question? Somebody was asking. Somebody was asking a question. Go ahead. You forget or what? Okay, let's move to something else. The momentum of an object, momentum. Do you remember the momentum? Momentum is mass times velocity. Momentum. The momentum of an object is 20 kilogram meter per second. The kinetic energy is half mv square. Take care of something. This is the velocity, and this is the speed. Okay. Okay. Equals 40 joule. What is the mass of the object? What is the mass of the object? So the momentum is 20, the kinetic energy is 40 joule. Find the mass of the object. How should we solve this one? What do you think? Can anybody guess how to solve it? What do you think, guys? I have two equations here. mv equals 20 and half mv square equals 40. What do you think? Okay, Asil, go ahead.
We can make the two equation equals each other. Like we can in B, in the momentum, we can make the V the subject, and in key E make the V the subject and equal each other.
Oh, equate them. Okay, that's an idea. Like you want to take mv or what? mv? Like the energy, you want to write it like half mv times v, and then you can take the mv here
To the other side.
equals 2 times 40 over v, and then equate it to the 20.
Yeah, I think like this.
Okay, that's an idea actually. It works. Okay, it works. Or mathematically, we can do what? We can divide equation number 2 over equation number 1. We can divide 2 over 1, and it gives you something similar. Okay. Anyway, let's use the idea that you proposed here. So 80 over V equals 20. Okay. So V equals 8 over 2. So V equals what? 4 meter per second. So we found the speed. Then he wants what? He wants what? The mass. So we can go and plug it back here or here in any equation, 1 or 2. Number 1 is easier. So I will say mass times the speed, which is 4, equals 20. So the mass is 20 over 4. That's 5 kilogram. Okay?
Doctor,
Yes, Rasim. Yes, go ahead.
why you equal them? Based on what?
Based on what? I have mass and I have speed. Okay, because it's the same object. It has the same speed and the same mass. I know that mv is 20. While half mv square equals 40. So I have the same variables. I have mass here and here, and I have a speed here and here. So I want to solve the two equations.
Yeah.
So you can divide 2 over 1. When you divide 2 over 1, it will be half the mass goes with the mass, and the square goes with the v, so it becomes half v equals 40 over 20. 40 over 20 is 2. So v equals 4 meter per second. Then take it back, plug it here. Mass times v, m times v is 20. V is 4, so m is 5. Okay?
Yeah, thank you.
Let's solve this one. A boy starts at rest to slide down. So his speed now is 0 at the beginning. Let's call it point A. Slides down a frictionless slide. Frictionless, so we can conserve energy. We can conserve the mechanical energy. And in the figure below, the bottom of the track is at a height h. This bottom is at a height h from the ground, as you can see it here. Okay. The boy then leaves the track. The boy then leaves the track horizontally. When he reaches to the bottom, he leaves the track horizontally with a speed, let's call it VH, or let's call it not VH. Let's call it, this is point B, let's call it VB. Striking the ground. He will strike the ground. So he will move like a projectile, like this part, the second part of this problem. He will treat the boy as a projectile. Okay, when he reaches to the bottom, he will move with a speed VB, horizontal speed, and then he will jump as a projectile. Striking the ground at a distance D as shown. So he reaches actually to point D here. So he moves with a speed VB and a distance D, a height H. What is the initial height H, big H here, of the boy in terms of H and D? Actually, these are two problems. One problem. The first problem is you need to apply conservation of energy between point A and B, between the point A and point B. Let's try to do it. The mechanical energy is conserved. So mgh plus half mv square at point A equals mgh plus half mv square at point B. Okay, guys? He says the object this boy starts from rest. V initial equals 0, or VA equals 0. So I can remove this part. The initial kinetic energy is 0. I don't need it. Then I can cancel also the masses, all the masses together. So G times the height at the beginning is the big H. this is the height at the beginning, equals g times the other h, which is the small h, plus half times VB square. Take care that VB will be the initial speed for the projectile. Okay, the initial speed for the projectile. Okay, so this is an equation. Let's save it for a while here and try to work with the projectile. I have a projectile. It has an initial speed VB. It has a horizontal distance x and a vertical height h. How to make an equation that has VB and d and h? I need the three variables together. Let's start with the horizontal equation of the projectile. X equals V initial times t. X here is the distance d. V initial is the speed VB, and the time is t. And there is another vertical equation. H equals half g t square. Half g t square. I need to remove the time from both equations, so I would say what? From the equation, the time is what? Is 2 times h over g. Take the half to the other side becomes 2. Take the g to the denominator, and then the t is squared. To remove the square, you need to take a square root. So we got the value of t. Then plug it in the first equation. So d equals VB times root of 2h over g. So now we have an equation that has the distance d, the height h, and the speed VB. So now we have two equations here. We need to work together or work them together to get what? What we are looking for. We are looking for this h, this h. So I will divide this equation over g. I will divide the equation over g. So this g will be removed with this g, and this part will be over g. So let me write it again. H plus this, and the half can go to here. So it's better if we write it this way. H, big H equals a small h plus whatever. So we need to remove this VB. Okay, from here, let's take VB in a side. VB equals what? D times root of, let's flip everything, G over 2H. I take it to the other side and flip it, right? And then we will need to square it, because when I want it here, I need it squared. Okay, so square it will make D squared, and I will remove the square root. Okay, guys? Do you follow me? Now it's ready. Then let's take it and plug it here in this equation. So H equals the small h plus 1 over 2g, 1 over 2g times v square. I will take all of this stuff. It's d square times g over 2h. Okay? Simplify. We can remove this g with this g. So h equals small h plus 1 over 2 and 1 over 2. It will be 1 over 4. And I have d square in the numerator and h in the denominator. I'm trying not to do any mistakes, not to make any mistakes. Is it the right answer? Is it the right answer? H plus d square over 4h. That's right. That's right. Huh. Understand it? Understand? So we work two equations. The conservation of energy at the beginning and the projectile here. Then we take the result here from the result there. We solve the two equations together. Okay. Takes some time, but at the end, you can solve it. This equation is okay. Okay. So I think this is like the longest problem that you have ever solved, maybe. If an astronaut can jump straight up to a height 0.5 meter on the Earth, if he jumps, he can jump 0.5 meter. How high could he jump on the moon if his initial speed is the same? This is Earth and this is moon. Of course, on the moon, he can jump higher, h, because it has lower gravity. Like the gravity there is 1/6. Gravity on moon equals 1/6 of our gravity. But the point here is what? It has the same, or he has the same initial speed. The same initial speed. What does it mean if he has the same initial speed? If he has the same initial speed, he has the same mass. So he has the same kinetic energy, the same initial kinetic energy, right? Because kinetic energy equals half mv squared. It depends on mass and speed. He is the same astronaut, so he has the same mass. And he says he has the same initial speed. So the kinetic energy, the beginning kinetic energy of him on the Earth is the same like his kinetic energy on the moon. When he jumps up and reaches to the maximum height, all of his kinetic changes into what? Changes into potential. All of his kinetic changes into potential. Okay, as we said before, there is a conservation of energy, so kinetic energy at the bottom equals potential energy at the top. Okay. Also, when he go to the moon, and his maximum height, whatever, h, we said it's h. I think we took it here. So it's his potential energy also when he goes to the moon, it will be mgh. But this h is on the Earth, which is only half, and this gravity is the gravity of the Earth. While when he goes to the moon, h will be much higher. Okay, but the gravity there, this is the gravity at the moon. This is the gravity at the moon. Equals what? Equals our g over 6. So now we can equate the mechanical energy or the potential energy on the Earth to the potential energy on the moon. Why? Because he has the same kinetic energy, so the same potential energy. So mg times 0.5 meter equals the same at the moon. The gravity is g over 6 times the height on the moon. Remove mass with mass, remove g with g, so h over 6 equals half, which is over 2, so h equals 6 over 2, that's what? 3 meters. So you can jump 3 meters up on the moon. 3 meters. I think this one is not hard. Once you get the idea that the two kinetic energies are the same and the kinetic energy equals the potential energy, so you can equate the two potential energies. It's a good idea also. A 100-kilogram person climbs stairs gaining 3 meters in height in just 5 seconds. Climb stairs, reaches from point A to point B, a height h 3 meter. He did that in a time 5 seconds, and his mass is 100 kilogram. Find the power of the person. Find the power of the person. Power equals what? Work over time. What's the work of the person to lift him up or to move him up from the bottom to upstairs? mgh. mgh divided by t. So mass is 100, g is 9.8, the height is 3 meters, divided by the time 5 seconds, and you can, how much is it, guys? 500 something? 580 something, I guess. Try to do it. What? 588. 588 watt. Okay? So again, the work done to move any object a certain height h, it's mgh. mgh. Okay? So this is the power of the person. Question? "20 kilowatt electric motor provides a power for the elevator of a building." So the power is 20 kilowatt. What is the minimum time needed for the elevator to raise 15 meter? This is the height. Its total mass is 500 kilograms. So I know the mass, I know the height, and I know the power, and he needs the time. So I will say the power equals the work over time, and the work to lift the elevator is mgh. Okay, divided by t. So I would say 20 kilo, which is 20,000, equals the mass, which is 500 kilogram, times 9.8. The height is 15 meter, divided by time, so we can get the time. Okay, guys? A crate 3.67. Are you sure? 3.675. Okay, but I haven't calculated actually. A crate weighs 950 newton. So this is the weight of the crate, 950 newton. If you can use a pulley system to lift the crate with a force, only you can use a force 250. So this is your force, and you will lift this W. So this is the input, and this is the output. Because this is the force that you apply, and you need to lift this weight. So this is the output for this machine system. Then what is the mechanical advantage? Mechanical advantage equals what of a machine? The output force over the input force. The output force in this machine is 950, and the input force is 250. Okay? It gives you 3.8 times. So the mechanical advantage is 3.8 times. Okay, guys?
Doctor.
Yes.
Doctor. Why we said
Yes.
that W is F output?
Actually, if you have a pulley system like this one, usually the pulley system, why do you need a pulley system? To lift a certain weight. You have a weight and you need to lift it up. This is the purpose of using a pulley system. Okay? So if you are here and you will pull the rope down, you pull it down. So you do a work. This is for the machine is the input work. And why there is a machine? There is a machine because we need to lift this weight up. So this is the output work. You understand?
Yeah, I got it. Thank you.
Okay.
Yes, yes.
Huh? What else? Which of the following statements is true? Bicycle is a simple machine. Is it a true statement? No. Bicycle is a compound machine. Chemical potential energy is a mechanical energy? Of course not. Chemical potential energy is not a mechanical energy. The gravitational potential energy is mechanical. The elastic potential energy is mechanical. The kinetic energy is mechanical. But chemical energy is not a mechanical energy. The rate at which energy is converted from one form to the other. The rate, we said it at the beginning of the lecture. The rate at which energy is converted from one form to the other is called what? What is it?
Power.
Change of E over T, that's power, not the acceleration. So this is power, not acceleration. So that's not right. Work doesn't have a direction. This is true statement. Work has no direction. Work and energy are scalar quantities and they have no direction. So I think that's let's I think I solved everything else in the other videos. So that's enough for today. I know you have an exam.